Okay, get out your notebooks. Today's lesson is 12.2, experimental probability. You need to write the information that is in this box in your notes. It says the probability of an event is equal to the number of times the event occurs over the total number of trials. Once you get that copied down, you can pause the video if you need to. We'll go on to an example. So we want to find the experimental probability of making free throws. And what experimental probability is just like doing an experiment. How many times do you make a free throw out of how many times did you shot the basketball? So you attempt 16 free throws in a basketball game. Your results are shown. What is the experimental probability of making a free throw? So we want to know, what is the probability of a free throw? So we're going to have number of free throws. What is wrong with this? Free throws made over free throws attempted. Okay, so if we look at this and we count the results, how many free throws did you make? 1, 2, 3, 4, 5, 6, 7, 8. Let's count this one more time. 1, 2, 3, 4, 5, 6, 7, 8. 8 free throws out of how many free throws were attempted? Well, they tell us here that 16 free throws were attempted, so it would be 6 out of 18. And we want to reduce that, so we can divide the numerator by 8 and the denominator by 8. So when we reduce it, we get 8 divided by 8 is 1, and 16 divided by 8 is 2. So you have this person has a 1/2 chance of making a free throw, or 50% chance of making a free throw. All right, I have some examples that I want you to try. So you can pause the video and try this problem, and then when you're ready, turn it back on and we'll see how you did. In 60 coin tosses, 25 are trials. Find the experimental probability. Or in 60 coin tosses, 25 are tails, not trials. Find the experimental probability. So we want to know, what is the probability of tails? So we want the how many times are tails tossed over total tosses. So tails are tossed 25 times out of 60 tosses. Now we can reduce the fraction because they both end in 5, so we can divide the numerator by 5 and divide the denominator by 5. And we do that. 25 divided by 5 is 5, and 60 divided by 5 is 12. So we have a 5 in 12 chance of tossing tails. Okay, so how do we apply these problems? A bicycle company checks a random sample of bikes. The results are shown. If the trend continues, which is the best prediction of the number of defective bikes in a batch of 1,300? So what we're going to do here, I'm going to cover this part up, and then over this together. Okay, so we know that we're going to go back to using proportions. So we're going to have defective bikes over the bikes checked. So we start out with 12 defective bikes and they check 400 of them. So that's one of the probabilities. Then we want to know how many bikes will be defective in a batch of 1,300. So now we're looking for x. So when we multiply, we're going to cross multiply. 400x equals 12 times 1,300. I have to use my calculator for that, which is 15,600. Then to solve, we divide by 400. So that means x is equal to 39. So in a batch of 1,300, there would be 39 defective bikes. Okay, so let's look at this. How many? Oh, we just did that problem. Let's try these on your own. Tad makes 7 free throws out of 12 attempts. Based on this, what is the experimental probability of this player making a free throw? Stop the video and try this problem. When you're done, come back and we'll check your work. Okay, so we want to know the probability of free throws. So we're going to put free throws over attempts. So we have 7 free throws over, I don't know what's wrong with my pen today, 12 attempts. So we can't reduce it, so it's just, you have a 7 in 12 chance of making free throws. So now we're going to do a little prediction. Let's predict the number of free throws Tad will make if he attempts 100 free throws. So we have made over attempts. So we know that he made 7 out of 12 attempts. We want to know how many is he going to make if he attempts 100 free throws. How many will he make? So we cross multiply. So we have 12x equals 700. We divide by 12. And x is equal to 700 divided by 12. I'm going to use my calculator. That's fine to do that, which is 58.3. So Tad will make about 58 free throws. Okay, let's look at if we simulate an event. So when we find the experimental probability that 2 of 3 children in a family are girls, assume that girls and boys are equally likely. We're going to simulate the problem by tossing 3 coins. Heads represents a girl, so H is equal to a girl, and tails represents a boy, so T is equal to a boy. So here's a sample of We have 20 different coin tosses shown. So what's the probability of 2 girls? That's going to be anything that has 2 H's because we said H was girls. So we have 1, 2, 3, 4, 5, 6. So we have 6 that have 2 girls out of 20, or we reduce that 3 out of 10. So there's a 3 in 10 chance that there's a probability that 2 of the 3 children are girls. So what is the experimental probability that all children will be boys? So remember, T is equal to boys. We're going to ignore the pink circles then here, okay? So we want to know 3 boys out of all the possible outcomes. So we know that there are 20 different outcomes. So what is the probability that we get all boys? That means we have to have 3 T's. So it's the only one. So it's a 1 in 20 chance that we get all boys. So 1 out of 20 that all 3 are boys. Okay, that's all for today. Write down your questions and bring them to class tomorrow. Thanks.